Hello, all in Ethiopia. Good afternoon. This is Diego Pedreros. It is very nice to be with you again, even though we are so far away. So, in the next few minutes, I'm going to show you the analysis that we've done with Deriva on the differences in anomalies of RFE and chirps during the 2014 June, July, August, September season. So, please give us any comments or questions, and so we can improve this work. Thanks. The whole thing began with the question of why RFE and ARC anomalies were so different to those of chirps. RFE and ARC for the 2014 season, June, July, August, September, were showing positive anomalies in most of the country, while chirps was showing dryness. So this is an example of June, July, no, July, August, September 2014. Left is chirps and right is RFE. We see that the two are opposite values. So based on some preliminary analysis that Pete Peterson did, he said that the reason why the two different anomalies or the anomalies were so different was because of the means of the two data sets were different. So we decided to go and do an analysis of averages of long-term means first, and then look at the actual values for the 2014. So to look how different were the means and how different were the observed values for 2014. So the first thing was then collecting station means. NMA provided 900 and something stations with averages. We selected, they have different values of levels of quality control, so we collected only stations for the levels 1, 2, and 3. These are stations with high value quality control, and even though not all the stations had the same time series, we took them because that's the only thing we had. So the whole idea was to be able to have stations from with long-term averages, but not all of them have the same length of the times in the time series. So then NMA provided 150 stations with actual observations from 1981 to 2015. Again, not every month has 150 stations. Some months have 9 stations or so. Then the number of stations, the density of the stations is varies very much in some cases. So that's the station data. So what I did is I took the average values for every month and I interpolated and created monthly fields of averages, and I used those monthly fields to interpolate the observed values. Then I came up with a time series 1981 to 2015 fields monthly. Then NMA provided for ENACT, they provided 5,000 points for the entire country. I interpolated those and came up with monthly fields for ENACT. Then having RFE. So once we had the time series for each of the estimates, we calculated the seasonal average for June, July, August, September. This is RFE, CHIRP, R2, ENACT, CHIRPS, and the interpolated stations. So just as a visual analysis, we started looking at this, and we noticed right away the big difference between RFE and ARC with the average of all the other four. Then you notice that the high values for RFE and ARC are to the left of the country, right on the western part of and move to the north, so northwest, while the others, the stations have the high values right in the highlands, and so is ENACT. Well, ENACT has the stations in it. So uh, there is a difference right there. Also, the RFE and ARC don't have much of high values. So especially ARC doesn't have high values as the stations do. The same thing with RFE. It has some high values, but again to the northwest. So this is the first visualization of the averages. Then I calculated the difference between each seasonal average with the stations. Then here is the RFE minus the stations. We see that in most of the country the average RFE is lower than the stations. This is chirp is showing a mix, and the same ARC is showing the same pattern that RFE. This is ENACT, which is the closest to the stations, and this is chirps. Then I took for each of the stations, I extracted the values for each of the rasters in the average rasters, and this is a plot of chirps, RFE, and the stations. This plot should be in bars, but when I put it in bars, it's difficult to read. So what this is showing is on the green is RFE. So RFE is showing this is not a time series. This is just for each station. So we see that in most cases RFE is lower than the value of the station in black. Then I used the same point to do a comparison of each of the estimate with the stations. So this is chirp. We see that the ARC square is 79%. Chirps moves a little better in the R square, and we notice here in RFE that again this is confirming what we were saying before, that the high values are not there. So this is the maximum high value here is around 1100, while on the stations it's almost 1600, so 1500. So we see that there is a cap on the high values in RFE. The same thing with ARC2. Then I got here some error analysis. The one that is telling us very clear is this average error. This is ENACT is 27, chirp is 57, chirps is 16. So these are a little bit overestimating, while the ARC2 and RFE are negative, very high negative values compared with the stations. So this is telling us that RFE and ARC are much lower than the average of the stations. So I ran t-tests for each of those ENACT and the stations, chirp and the stations, and so forth. And so this is telling us that the difference between ARC and the stations is significant. The same thing with RFE. While the other two, the other three, the difference is not significant. So this is in summary the analysis of the averages. So there is a significant difference between the average of RFE and the average of the stations, and the average of R2 and the average of the stations. Then we moved, let's go directly to this one, and then we go back. This, after we looked at uh, the averages, the long-term averages, then we wanted to see how different was the seasonal total for 2014 for each of the estimates with that of the stations. So this is again a visual comparison of the seasonal total. So we see each of the estimates. In this case, RFE and ARC are showing high values as the others, but again, those high values are moved to the northwest. So, but in terms of the pattern is similar in all of them. Then, based on this, I calculated the anomalies for each of those estimates, and we see that RFE and ARC are showing high positive anomalies. Oh, I forgot to put the scale, but so greens are positive anomalies, yellow to brown are negative. So we see the difference here, and this is what we were seeing in 2014. So we see that ARC and RFE are showing positive anomalies, while the others are showing some negative anomalies in most of the country, and some areas with positive anomalies. So I extracted again the values for the stations for that we have for 2014. We have 109 stations, and it's important to note that for chirps, we only had, when at the time chirps was created, we only had 39 stations that went into chirps. So, but in this case we have 109. So I extracted all the values for each of the estimates for those 109 stations, and these are the scatter plots. The scatter plots don't tell us much difference between them. They're like the scatter plot for RFE is a little more scattered on the high values, but the difference is not very big. Then I wanted to see how, if there was any significant difference. I ran an ANOVA, and it tells us that no, all of them are within the same overall distribution, so there is no significant difference between them. And when we look at in this table, I have, this is the long-term average on the top, and this is the seasonal average on the bottom. So we see that within the seasonal average for 2014, the two that we are comparing, RFE and chirps, are very similar, 628 and 615, and not very far from the stations. So this graph summarizes the whole thing. Here we are comparing the long-term average in blue and the seasonal total in orange, and we see that in stations, chirps, chirp, and enact, the long-term average is higher than the seasonal total for 2014, while in ARC and RFE, the long-term average is much lower than the seasonal total. So, and that is why we are getting positive anomalies for these two and negative anomalies for the others. So that is in summary of what we have so far. We have done a few extra things. For example, we estimated the trend that is looking at the whole time series 2001-2015, and this is the trend. This is a positive trend for RFE and positive trend for ARC in most of the country, while the others, the stations primarily, is showing negative trend for some parts, mainly the central north of the country, while the in the south is showing some positive trends. So this is showing us also the difference between the different rainfall estimates. We take a look at this graph that is showing the percent anomaly of each of the estimates chirp, chirps, enact, RFE, and ARC with the stations. So this gray line right here is enact. It's very close to the stations. So it's the purple is chirp, the orange is chirps, yellow is RFE, and blue is ARC. So we see that enact is very close to the stations, so is chirp and chirps, and these two estimates have a trend that we saw in the previous maps, and telling us that as time goes by from 2000, these estimates are getting closer to the stations. One hypothesis that Pete Peterson has is that in these times, the stations from JTS have a lot of false zeros. What he calls false zeros is data values that they were supposed to be no data, and they are replaced by zeros. So then this problem has been resolved better at the end of the time series. So these values are more accurate than the values down here. So the false zeros are pulling these values of these two estimates down into more drier. But then as they get resolved, there is more accurate values in at the end of the time series. So that's one hypothesis of why these two data sets have trend. So this is the conclusion of the analysis of the 2014 Enigma of why the anomaly for chirps was so different or opposite to that of the RFE. Please let us know if you have any questions so that we could improve this work. Thanks.